Hello everyone. Hello. Next, I will introduce to you the content related to electricity bills and prices. Before understanding this content, please think about how the electricity bill is generated after using electricity. Is it similar to buying things where knowing the price lets you know how much to pay? Actually, to understand how the electricity bill is generated, the first step is to understand the classification structure of sales electricity prices. According to the National Development and Reform Commission, number 973 of 2013, regarding the issue of sales electricity price classification structure, it is stated that sales electricity prices are classified by industry and usage and adjusted to be categorized by the characteristics of electricity load, divided into residential electricity, agricultural electricity, and industrial and commercial electricity, and other uses. That is to say, sales electricity prices have three types of prices. Part 2. Electricity calculation. When familiar with our electricity use and the corresponding price category, the second step is to understand how much electricity is used, which is the settlement electricity. It includes, first, active electricity. Settlement electricity equals meter reading plus transformer loss plus line loss plus refund divided by compensation electricity. 2. Reactive electricity. For low supply and low measurement, reactive electricity equals forward reactive plus the absolute value of reverse reactive. For high supply and high measurement, reactive electricity equals forward reactive plus the absolute value of reverse reactive plus reactive line loss. For high supply and low measurement, reactive electricity equals forward reactive plus the absolute value of reactive transformer loss plus the absolute value of reverse reactive plus reactive line loss. Copy the electricity calculation. A. Meter recorded data. First, normal wiring. Meter reading equals current reading minus previous reading or times comprehensive multiplier. Second, meter rollover. Meter reading equals current reading plus 10 positions minus previous reading or times comprehensive multiplier. Third, reversed wiring. Meter reading equals forward electricity plus reverse electricity or times comprehensive multiplier. Fourth, fault meter replacement. Meter reading equals new meter reading plus old meter reading or times comprehensive multiplier. Example 1. A certain middle school uses public transformer power supply, originally installed one low voltage meter, current transformer ratio of 300 divided by 5. On the 5th of this month, replaced with a low voltage smart meter, with a current transformer ratio of 400 divided by 5. The old meter had a reading of 19880 at the end of last month, and the reading at the time of replacement was 20450. The new meter had an initial reading of 2, and This month reading is 00688. How much electricity did this customer use this month? Solution. Old meter reading equals current reading minus previous reading all times comprehensive multiplier equals 20450 minus 19880 all times 300 divided by 5 equals 34200 kilowatt hour. New meter reading equals current reading minus initial reading all times comprehensive multiplier equals 00688 minus 4 times 02 all times 400 divided by 5 equals 54880 kilowatt hour. This month's electricity usage equals old meter reading plus new meter reading equals 34200 plus 54880 equals 89080 kilowatt hour. Fixed ratio and fixed amount. In reality, we know that most customers have different electricity usage categories. Often, the power company uses meters to separately measure the corresponding electricity. But there is also a situation where customers use multiple categories of electricity mixed on one line, making it impossible to separate. So, how to solve the electricity measurement? In fact, when encountering this issue, both the supplier and the user can resolve it through an agreed ratio or a fixed amount value in the contracts, known as fixed ratio and fixed amount. Specifically, fixed ratio electricity equals total electricity times agreed ratio. Fixed amount electricity equals agreed amount value times meter reading period. Example 1. An industrial customer with a 315 kilowatt ampere transformer using 10 kilowatts high voltage power supply, measured on the high voltage side. The customer's current transformer is 25 divided by 5. In March, the active total meter reading was 2,600, with a peak reading of 750 and a valley reading of 830 and a reactive reading of 1,900. In April, the active meter reading was 2,900, with a peak reading of 860 and a valley reading of 920 and a reactive reading of 2,100. The customer's office lighting uses a fixed ratio of 15%. Calculate the customer's production and lighting electricity for April. Solution. Total meter reading equals current reading minus previous reading all times comprehensive multiplier equals 2,900 minus 2,600 all times 25 divided by 5 times 10,000 divided by 100 equals 150,000 kilowatt hour. Production peak meter reading equals current reading minus previous reading all times comprehensive multiplier equals 860 minus 750 all times 25 divided by 5 times 10,000 divided by 100 equals 55,000 kilowatt hour. Production valley meter reading equals current reading minus previous reading all times comprehensive multiplier equals 920 minus 830 all times 25 divided by 5 times 10,000 divided by 100 equals 45,000 kilowatt hour. Office lighting electricity equals total meter reading times 15% equals 150,000 times 15% equals 22,500 kilowatt-hour. Production off-peak electricity equals total meter reading minus production peak meter reading minus production valley meter reading minus office lighting electricity equals 150,000 minus 55,000 minus 45,000 minus 22,500 equals 27,500 kilowatt-hour. Main and submeter. 1. Main and submeter deduction order. First, deduct the electricity of the transferred user. Then deduct the actual submeter reading. Finally, deduct the fixed ratio and fixed amount electricity. 2. Main and submeter deduction calculation. 1. Calculate each submeter electricity separately. 2. Calculate for transferred users and sub-users. 3. The main meter electricity is not equal to the submeter electricity. Example calculation. An industrial customer with a 315 kilowatt-ampere transformer using 10 kilowatt high voltage power supply measured on the high voltage side. The customer's current transformer is 25 divided by 5. In March, the active total meter reading was 2,600 with a peak reading of 750 and a valley reading of 830 and a reactive reading of 1,900. The customer's office lighting submeter reading was 3,100 with a peak reading of 1,200 and a valley reading of 980. In April, the active meter reading was 2,900 with a peak reading of 860 and a valley reading of 920 and a reactive reading of 2,100. The customer's office lighting submeter reading was 4,700 with a peak reading of 1,600 and a valley reading of 1,280. Calculate the customer's production and lighting electricity for April. Solution. Main meter total reading equals current reading minus previous reading all times comprehensive multiplier equals 2,900 minus 2,600 all times 25 divided by 5 times 10,000 divided by 100 equals 150,000 kilowatt-hour. Main meter peak reading equals current reading minus previous reading all times comprehensive multiplier equals 860 minus 750 all times 25 divided by 5 times 10,000 divided by 100 equals 55,000 kilowatt-hour. Main meter valley reading equals current reading minus previous reading all times comprehensive multiplier equals 920 minus 830 all times 25 divided by 5 times 10,000 divided by 100 equals 45,000 kilowatt-hour. Main meter off-peak electricity equals main meter total reading minus main meter peak reading minus main meter valley reading equals 150,000 minus 55,000 minus 45,000 equals 50,000 kilowatt-hour. Lighting submeter total reading equals current reading minus previous reading all times comprehensive multiplier equals 4,700 minus 3,100 all times 25 divided by 5 equals 8,000 kilowatt-hour. Lighting submeter peak reading equals current reading minus previous reading all times comprehensive multiplier equals 1,600 minus 1,200 all times 25 divided by 5 equals 2,000 kilowatt-hour. Lighting submeter valley reading equals current reading minus previous reading all times comprehensive multiplier equals 1,280 minus 980 all times 25 divided by 5 equals 1,500 kilowatt-hour. Lighting submeter off-peak electricity equals lighting submeter total reading minus lighting submeter peak reading minus lighting submeter valley reading equals 8,000 minus 2,000 minus 1,500 equals 4,500 kilowatt-hour. Therefore, production peak electricity equals main meter peak reading minus lighting submeter peak reading equals 55,000 minus 2,000 equals 53,000 kilowatt-hour. Production valley electricity equals main meter valley reading minus lighting submeter valley reading equals 45,000 minus 1,500 equals 43,500 kilowatt-hour. Production off-peak electricity equals main meter off-peak electricity minus lighting submeter off-peak electricity equals 50,000 minus 4,500 equals 45,500 kilowatt-hour.